odd and even functions before we pick a question so that we appreciate it more. So we have even and odd function, even and odd functions. We have even and odd functions. So let's pick the first one. So we have even functions. The first thing we will discuss under even function is, let's do the algebraic representation. The algebraic representation. Now, the rule for even function is that f of negative x is the same as f of x. We learned this in engineering maths 1. If a function is said to be even, then if you place the x by negative x and you solve it, you simplify it, the answer should be the same as when there's no negative. Example. If I give you the function f of x is equal to, let's say, x squared. Now I want to test whether it is even. So I replace the x by negative x. That will give me x replaced by negative x. The square is on this. Now let's simplify this and see. This is the same as negative 1 squared x squared, which gives me x squared. X squared is the same as the original function f of x. X squared is the same as, so this is f of x. So we can see that f of negative x is the same as f of x. So that means that this is an even function. Okay, so that is what we mean by the formula for, the algebraic formula for even function. Now, case 2. Case 2, we are talking about the graphical. The graphical. When the function is even, in graphically, how would it look like? Look at this. This graph has been drawn for you. Look at it carefully. Now, if it is even, if this graph is even, then the rule is that, just as I wrote the rule for this one, the rule is that it is symmetrical about the y-axis, symmetrical about y-axis. In other words, complete it such that the symmetry will be in the y-axis. So here the symmetry should have been here. So here this is the symmetry. If I complete my graph this way, it means that this is the symmetry. So any graph that is even, it has a line of symmetry or a mirror line in the y. So when you complete this graph in this format, it means that it is an even function graph. So let's move on to the second one. That is odd function. Okay. So case 1 is the algebraic form. So the formula is that if a function is odd, f of negative x is the same as negative f of x. F of negative x is the same as negative f of x. So note it carefully. Now let's look at the graphical. Let's look at the graphical form. So case 2, the graphical form of odd function. The graphical form of odd function. The graphical form of odd function will take this form. The rule, I'll write a rule first. The rule says reflects in x-axis, so reflects in y-axis plus reflects in x-axis. That's the rule. So first of all, reflect whatever that you have in the y-axis. When you finish, reflect that result in the x-axis. So if I have to put a question like complete this graph to make it an odd function, and the graph is drawn as this. The graph is drawn as this. Complete it to make it an odd function graph. And because the rule for graphical odd is that reflect whatever you have on the x-axis, on the y-axis. When you finish, reflect whatever you have on the y-axis, also on the x-axis. Okay, so the first thing we do is that we draw the graph again. This is x and this is our y. This is the question, 0 and e. When I reflect this on the y-axis, it will fall here. So we'll have here. Now it is here. Now when we reflect this on the x, this is the x-axis. First of all, reflect the given question on the y-axis. When I reflect this on this y-axis, it will fall here. Now we are here. When we reflect this on this x-axis, it will fall back here. So when it falls back here, it will be like this. So our final answer is this. Our final answer is this and this. Our final answer is this and this. So this is the complete graph for a function like this that will make it an odd function graph. So note it carefully. The rules are very important. I've given you both the algebraic definition of an odd function and even function, and also a graphical representation of that. We need it to do Fourier series problem. Okay, any question? Okay, let's continue. Case 2. We do case 3, then we pick the entire question because we may need these deductions. Okay. Okay, so we move on to the case 3. The case 3 is the Bn equals 1 over pi, that's a negative a to a, f of x sine nx dx. We just want to check whether the whole of this is odd, is even, and what happens to the integration. So we have a. We know this is odd, always. Sine function is odd. This one can be odd or even because this is not specific. Okay, so let's do the analysis here. We have odd times odd is equal to odd. Example is s cubed times x. So odd times odd is equal to even. Odd times odd is equal to even. So we have s cubed times x5 is equal to x4. You see that this is even. Now, odd times even is equal to odd. Let's see. S cubed times x squared is equal to x5. You see that this is odd. Okay. So when this is odd, so then it means that with these two things, it means that if I'm integrating from negative 2 to 2 of x4 dx, because this is even, it's the same as 2 times 0 to 2 x4 dx. For the first one, for this one. If whatever here is even, then it will be 2 times that answer. But if it is odd like this, negative 2 to 2 of s cubed dx. Because this one is odd, there's nothing I can do. You get 0 straightforward. Because it is odd, you get 0. If it is even, it will be 2 times half of that interval. Okay. So these ideas are what we're going to apply in solving questions under Fourier series. So let's pick a general question.